Oh. All right. No daily quiz. I told you. Yesterday. Do we have anything from on 2-3 or 2-4? I don't know pages. Okay. 58. Okay. Use graphs and synthetic division to completely factor each polynomial. Based off of this, I know that there's a x plus 5 right there. I know there's a likely x minus 3 there. And then I've got 2 that are somewhere. So if I know those 2, then I know x squared plus 2x minus 15, the quadratic that they create, has to somehow go into this. 8x to the fourth, 26x to the third, minus 103x squared, minus 156x plus 45. Oh, do it long chain. Okay, that's better because I don't want to do that. So I have 8, 26, negative 103, negative 156, 45. If I'm pretty sure that those go in, because it looks like those are zeros, then I feel really lucky about negative 5. And say negative 40, negative 14 is 70, is negative 33, is 150, 165, is 9, is negative 45. Yay, it works. So if I felt lucky about that one, I bet we'll feel even luckier about 3, 24, 10, 30, negative 3, negative 9. Yay! And then, what degree is that? This is now a quadratic. If this is a quadratic, 8x squared plus 10x minus 3, how about I just factor that? I know the only way I'm making a 3 is with a 3 and a 1. Can you mental math mojo a little bit of factors of 8 to find what that 10 would be, or do you got to go AC method on it? Okay. Okay, so whether you go AC method or you can get the mental mojo on it, you have those last two. Now write the fully factored form. There. Which is kind of the whole point of, if I'm trying to solve a polynomial, we've got all these theorems that narrow down our options to guess and check. But if I can just look at my screen, then I can just guess really well. Okay? Instead of using 3, 4 different theorems to narrow it down. And the goal of it is use what you know, synthetic divide down to a quadratic, and once you're at a quadratic, we know how to deal with quadratics. Either factor it, complete the square, quadratic formula, whatever your jam is. Okay? So it's reinforcing that idea before we get to the end of 2-4 here, where I just say, here's a polynomial, get it. Come on, you. Utters. All right. Before we get going into the lesson, couple things. Lunch meeting today for anyone involved or wants to or is even interested in the math competition thing. Again, they haven't had that for 2 years, so most of you don't even know that that's a thing. Spearfish is usually very good at it. We're not so hot at sports, but we crush in everything else. Okay, so we do okay. Okay. Now, okay, the problem is really we don't have a big enough school to support football and soccer at the same time. You're splitting the talent pool. We don't have our own baseball team, so if you want to do baseball in Spearfish, you have to pay an ungodly amount of money. So people will go to other places instead, and you split the talent pool. It just there's problems. We're at that medium size where we're trying to do too many athletic programs, and we don't have the student support to actually fill that. Now, if it was like it was 20 years ago, where 3/4 of the student body was in some sport, yeah, but kids just don't care now. Or I got a job, I gotta go work. That aside, if you're interested in that, the math competition, it's they do a practice once or twice a week. Just hey, we're gonna run through some stuff. Juniors being in that is really good ACT review, very good ACT review. And then you go to a thing in May, you do a little bit of math, they give you free food, you make eyes at all the kids from the other schools, and that's it. It's fun. Okay. Um, yeah, go do that. It's also at different levels, which is specifically why I'm talking to my pre-calc kids, because we had 3 sections of pre-calc this year. That means those 70 kids are the only ones who can even compete in level 4. Okay? They have Algebra 1, Geometry, Algebra 2, Math 4, and what they call Masters are the different levels of math competition. So you are literally the ones who can go. You two don't get a choice. Go over there for lunch. Okay? Um, so that's a thing. Remember today, if you are released from Spartan time normally, you do not have to show up. So you're allowed to leave at 11:24 if you choose. And today might be a train wreck because I'm exhausted. Baby Bear had us up twice last night because he's sick. So it's one of those situations where I might even sound like I'm drunk because I'm slurring my words. I'm so tired. Here we go! Right? None of you were in here when Connor was a baby, were you? You were. You remember the dark days. 7 straight months of an average of 3.5 total hours of sleep every night.
He would tell us to do our homework and then just pass out in his chair.
I would pass out sitting upright in my chair in the middle of helping a kid with their problem. Yeah, you do this and then you do that, okay? All right, finish this off. And then I'd wake up to giggles. Kids would come in at 7:30 in the morning and they'd find me passed out on the couch. Like all dark, and then I just hear this voice from the light of the hallway. Dude, you okay? Ah, it was bad. It was really bad. Anyway, math. We finished off with upper and lower boundary tests. Remember, the idea was do synthetic division. It's not going to work because it's not a 0. But when you do the synthetic division, you're guessing and checking, and you tried -2. And -2 ended up with plus minus, plus minus, plus minus, plus minus. That tells me there aren't any other zeros that way. -2 is a lower boundary. It just helps me to narrow down my options. The last thing that we do to narrow down our options is Descartes' rule of signs. Again, we aren't going to use any of these practically, okay? Boy, those are loud. We aren't going to use all of these different theorems to narrow down our options. They're just nice to know, particularly with standardized testing. Okay, I've said it enough times, I'm not a fan of standardized testing. I think it should just be eliminated altogether, personally, but that's our system. If you got to play the system, if you got to play the game, play it well. So I'm going to show you stuff like this because I know that this shows up on an ACT. Okay, Descartes' rule of signs, what it tells me is how many positive and negative real zeros I got to even try. If I plug in a positive x, okay, all of this is in mathese. If I plug in a positive x and I look at the sign changes, I count the sign changes, that's going to tell me how many positive real zeros are possible. If I plug in a negative and count sign changes, tells me the number of possible negative real zeros. So if I ended up with a positive, positive, negative, positive, negative, positive, that. Got a big long polynomial. I check the sign changes. These are the signs that I see. I would say there's 1, 2, 3, 4 sign changes. Now when I write the number of possible zeros, it's not just 4. Do you remember? Okay, let's say this is my polynomial. That's my graph. There's my x-axis. How many real zeros does it have right now?
6.
How many real zeros does it have right now? Still 6, multiplicity of 2 on that, right? And then 4. And then, assuming that 2, then why is it 6, 4, 2, 0? Why was there never a 5, 1, or 3 in there? Okay. How many real zeros? 1, 2, 3, 4, 5 real zeros. How many real zeros? 3. How many real zeros? How many real zeros? Why was it 6, 4, 2, 0, 5, 3, 1? Do you remember?
It's when there was an odd or even polynomial.
Okay.
Some law back. Is it the degree? Yeah, it's
Okay. It's going down in pairs every time. Why is it going down in pairs? Why doesn't it go 5, 4, 3, 1? Why is it 5, 3, 1? Why is it 6, 4, 2, 0? not 6, 4, 3, 2, 0.
Odds and evens.
Because.
Come on now.
On the first hour,
I'm calling them, you know, it's gonna have.
I have my algebra one.
Zeros.
Right here.
Because
I don't remember
the even polynomial is gonna have even zeros.
Yeah, it's algebra 2. Or algebra 2.
Okay. Getting warmer.
Would it be because every time there's a sign coming, that's
Okay. We're really sniffing down the trail. It's like that dog sniffing around. When are they going to find the squirrel that's sitting right next to them? Okay. I said these are the possible real zeros. What are the other kind of zeros? Imaginary zeros. What is an imaginary zero? It's got an I. How do I get I?
Negative square root.
Square root. And if there was a square root, there was a plus or a minus. They happen in pairs. Imaginary zeros happen in pairs. Because imaginary means there's an I. If there's an I, there's a square root. If I had a square root, I had to have solved by plus or minus square root of thing. So it had to happen in pairs. So there's 5 real zeros. Now there's 3 real zeros and 2 imaginary. Now there's 1 real zero and 4 imaginary, because they always happen in pairs. What that means is when I'm finding my number of possible real zeros here, I always have to take it down in pairs to say how many possible there were. If I look for the positive real zeros by putting in a positive x, none of this changes, right? Just plug in an x. So my signs are negative, positive, negative, negative. How many sign changes were there? 1 potato, 2 potato. So I'm going to say that there's 2, bring it down in pairs, or 0 possible positive real zeros. So if there were 4 there, I would have said 4 or 2 or 0. If there were 5, I would have said 5 or 3 or 1. Got to be careful how I count here. I actually got a picture of that. My kid was trying to count. He was like, we did it 2 times, 1, 2. And then he saw Daddy cracking up on the other end of the table, and he started just waving it in his mother's face and laughing. Made the whole family proud, kid. Like, I've got the pictures. It's great. It's so memeable, but I can't share it. If I put in a negative x, it changes because it's an odd number of negatives. If I put in a negative x, still positive because it's an even number of negatives, it won't change anything. I put in a negative. Now it's positive because it was an odd degree, it'll change the sign. And constants are just constants. I can't mess with it. It stays negative.
Would it be just 1 or would it be 1 or 0?
There was 1 sign change. Can I go down 2 from 1 and have that make sense? Can I say there's -1 negative real zeros? Okay, so 1 possible negative real zero. The reason this would be beneficial to me, if I don't have my crystal ball to look into for numbers, is I would look at this and say, all of my rational roots are all of these. Then I would do Descartes, and it tells me, why would I try the positive numbers first if it's possible that none of them work? I'm going to try the negative numbers first because I know there has to be at least 1 negative real zero. So I'm going to start with my negatives. And then when I find it, I know I don't have to try any more of the negative numbers because I've already found the one negative real zero. Now I'll move on to the positives and see what happens. Okay? It narrows down my options further. So, do it.
Get out of the box.
Negative, positive. Oh, no, negative, negative, positive. No, let's do this.
For positive.
Just one.
Okay, so for positive.
You get negative.
Right. That's right.
Oh, wait, no, no.
I see. Yeah, so it'd be one.
You get the real.
Yeah, right?
Oh dear God, tell me it wasn't that easy. Six, two. No, it's not. Okay. So, if I put in a positive x, it is what it is. Negative, positive, positive, negative, positive. I count my sign changes. 1, 2, 3. So, there are 3 or 1 possible positive real zeros. Do it again. Always down in pairs. If it was 9 sign changes, it'd be 9 or 7 or 5 or 3 or 1. Because these are possible real zeros. If they weren't real, they had to be imaginary. And if they were imaginary, they happened in pairs. So I have to take that total and keep bringing it down in pairs. If I plug in negative x, its even power doesn't change. Its odd power does change. Even power doesn't change. Odd power does change. Constant, technically that's x to the 0 and 0 is even, so it doesn't change. This time, I see only one sign change. So I just say there's one possible negative real zero, because I can't, like here, I can say 3 or 1. I can say 4 or 2 or 0, going down in pairs. I can't go down a pair from 1. So it's just one possible. This would tell me all of my factors over 18 over all my factors of 11, list them out. What are you going to start with if you have to guess and check? I know there's exactly one negative. I'm going to start with my negatives. because I know there has to be one of them, and when I find that one of them, I can disregard all of the other negatives because I know it's the only one. Okay? So it's just another way to narrow down our options. Okay, and then I tried doing that, and it hurt brain because sleep deprivation. But these ones we can talk about. You need to know how to factor. And this book now just skips over the fact that you can factor polynomials that are bigger than quadratics. You learned how to factor polynomials. First learned factor by grouping in Algebra 1 was the first time you saw it, but it was usually really simple, like maybe number 2. And then in Algebra 2, we saw that again along with quadratic form, like number 3, and sum and difference of cubes, like number 4. So these are all types that we've seen factoring. I know it says describe all the things. I don't care about that. We're going to use this for factoring practice. Do y'all remember this? This is taken from the Algebra 2 textbook. In Chapter 5, we did an awful lot of factoring and finding stuff with polynomials. That's what we're reviewing right now. Do you remember all the different ways to factor? Okay. Starting with at the beginning, I can factor out a GCF. Greatest common factor. Go away. I can factor by AC method. Perfect square trinomials. If A and C are both squares, you can possibly write it as square root of A term, square root of B term, plus or minus, will be the quantity squared. Then there was difference of squares. You can even use it when it's not a perfect square by just putting square root in there. What we've seen a couple of times in here, what's the only difference if that's the sum of squares? Okay. There's factoring by grouping. Factoring by grouping is when you already have 4 or more terms, and you're able to say, what does this stuff factor into? What does that stuff factor into? And then look for common binomials to keep the chain going. The one we may not remember, because we had less experience with it, was sum and difference of cubes. So if we don't remember that, you're going to want to write those down. The sum and difference of cubes. If I have a cubed thing plus or minus another cubed thing, and that's it, they factor into this special form where you have a linear factor and an irreducible quadratic factor, meaning it's going to have imaginary answers. You identify what was cubed to make the first term, what was cubed to make the second term, and then those are A and B, plug them in. Again, this book just assumes, well, you're in PreCalc, you did this. You know what's going on. So that's kind of what we do today, is a little pit stop, make sure that we know that stuff, and then tomorrow we continue with the rest of 2-4. All right. the example of it that they give, I would identify that my A is 2x, my B is 1, because they are the things that get cubed to make a 8x cubed and 1. So everywhere that there was an A or a B, I plug in 2x and 1. Be careful when you do that. I'll see a lot of kids goof this term up. They'll just write 2x squared instead of 4x squared because they only square the variable term instead of the entire thing. So, just a quick review on factoring. Get them. Factor this. It's factoring by grouping. Y'all got it? Took first hour a lot longer, sorry. Womp. I say I have a 2x minus 3 left if I take out an x squared. I have a 2x minus 3 left if I take out a negative 1. So 2x minus 3 taken out, I'm left with an x squared minus 1. But you got to remember that that is also factorable. And then because this is set them equal to 0 and solve, 3 halves plus or minus 1. Okay? So this is just reviewing different types from Algebra 1, or 2. Okay. Can you do quadratic form? We kind of did this. We did some quadratic form stuff earlier. If you got to go to the U method, that works. AC method. 36 by 1 is 36. What factor is a 36? Add up to negative 13. So I split my middle term. There we go. 36, x to the fourth minus 9, x squared minus 4, x squared plus 1. Take out a 9x squared. I'm left with a 4x squared minus 1. Take out negative 1. I'm left with a 4x squared minus 1. So 4x squared minus 1 taken out, I'm left with 9x squared minus 1. Each of those are difference of squares. Square root, plus minus conjugates. 2x plus 1, 2x minus 1. 3x plus 1, 3x minus 1. Set each equal to 0. Plus or minus 1/2, plus or minus 1/3. Yep.
Repeat it just because it's 1 at the end of it, and it's in a quadratic form, we can just go straight to something x squared minus 1 times something x squared minus 1 and find 4 and 9 that way.
What if the directions said solve by factoring completely?
Yeah. In this case, it doesn't, so is that fine?
We're practicing factoring right now. Can you do this?
That way?
Yeah. Okay. If the directions don't say that, yes. We are practicing the full skill now because what happens when that is specifically what they're asking for? What is the linear factorization of thing? Linear factorization, if I just go from here straight to here, would you then be able to recreate that?
No, we went to from 36x to the fourth minus 13x squared plus 1 to 4x squared minus 1 9x squared minus 1.
Oh yeah, if you got the mental mojo for it because 1 is just, okay, I thought you meant from here to here. No, if you don't need AC method to go from there to there, go for it.
Because it was 1.
Yeah.
Got it.
Okay. All right. Here we go. Can you factor it? You have to rearrange it. I'll start you there. I have to start by rewriting it like this. And that's not always apparent. Why? Okay, now look at them. Factorable thing, factorable thing.
Can you just split it in half and just do?
Try it.
That probably is right.
Yo. Why are we putting parentheses there? Remember, the forms are a cubed minus b cubed or a cubed plus b cubed. It's already taken care of in the problem. This is x minus 2, x squared minus 2x plus 4. Yes, it is.
You didn't put up our brownie points from yesterday. Yeah, you should.
I put up first hours. I didn't put up yours. Oops. Take out a 3x here. Do you see why now? If I see two things that are factorable, if I can rearrange this into factorable thing, factor two things, now look at them. Now look what happens when I take x minus 2 out and then combine everything that was left. I can keep going. Okay. And this is something that we usually in my Algebra 2, I introduce this. I have them practice it a little bit. They get kind of glossy-eyed, and then they just don't do it anymore. They do synthetic division into a quadratic formula. But if you ever have something that has rational roots to it, that means that it was factorable. It's just the factoring can be tough. For example, sometimes the factoring requires you to split a term even though there's already 4 or more there. I don't want to. So what's that? Plus 8, minus 4, 4, negative 4, that ain't going to work. Cut that out. Negative 2, positive 1. Negative 2, positive 1. 1, 4, negative 6, negative 2. All right, I'm going to hop down a rabbit hole quick. No, I don't want that. Because I can't mental math right now. No. Nope. Lost it. Sleep deprivation wins. Okay, so you can split a term here and then factor. I just can't think of it because children. If you run into larger polynomials, can you solve the entire thing using our synthetic division method we were doing yesterday? Find all zeros. What if it's bigger and uglier? Find them all. Solve the polynomial. Find everything. Okay. Now, when I'm not this sleep deprived, I'll come back and show you the factoring part. It's spooky, but I literally just can't think of the numbers right now. Okay. It involves multiple AC methods or a real good grasp of mental math. I can't do that right now. So, instead, I say 2, 9, negative 87, negative 49, negative 45. What? That's what I said. And what do we feel lucky about? I thought I heard a 5.
Yes.
Okay. The ether is confusing today. So I got 10. It's 19. I got 95 and negative 8 and negative 40 and 9. Positive, positive, negative 9, negative 45. So you think this is bad? You should have seen when Connor Bear was a baby. Negative 9. Okay, the ether is a little clearer this time. Negative 9 by 2 is negative 18. Get a 1. Get a negative 9. Get a negative 1. Get a 9. Get a skadoosh. Yes. This gets us to a quadratic. You solve the quadratic however you want. I can solve by factoring, complete the square, quadratic formula, or continued synthetic division. You can choose. Okay. Now, personally, I'm going to do, so what's that, 2x minus 1, 2x plus 1? Yeah. So 1 is the other one? Negative 1? 2, negative 1, 1, 0. And our last one was a half. So if I wanted the fully factored form of this, we have 2x minus 1, x plus 1, x plus 9, x minus 5. That's linear factorization. Okay. Now remember, that 2 is there because this says x minus a half. But it wasn't x minus a half, it was 2x minus 1. We had a constant left over. See how they're all rational zeros? If they're all rational zeros, that means that is factorable. Your teacher is just temporarily incapacitated. Okay? Are you okay with this? I can gaze into my crystal ball. I can do synthetic division until I get down to a quadratic. And when that quadratic is no longer factorable, quadratic formula or complete the square, whatever your jam is. Okay? And I'll cut it off there because I don't trust myself any further. Notice today we did very little because it was more of a side quest. And that's it. So, no assignment.